Today we're going to talk about another method for solving a quadratic. So far what we've done is we started with solving by factoring. Then we did solve by graphing. Most recently we've done solve by the quadratic formula. And now is our next method called completing the square. And when the quadratic equation cannot be factored, then the equation can be used by solving with the quadratic formula or something, as I just said, called completing the square. Well, the title of this is completing the square. And in fact, what we're looking at within completing the square is something like 25, which is a perfect square. Because it has two of the same factors. 5 times 5 is 25. But there's also called something, the name of x squared plus 6x plus 9 is called a perfect square trinomial. Remember trinomial, like tricycle? Tricycle has 3 wheels. Trinomial has 3 terms. X squared is a term, 6x is a term, 9 is a term. And all that a perfect square trinomial is it has 2 of the same factors. X plus 3, x plus 3. But what we need to practice here for a couple minutes, and I'm not going to do all of these, I'm going to focus on A and B, because those are more specifically what we're going to work with this year. It says find the value of C, which is the constant in this problem, that will make each trinomial perfect square. When we look at this first one here, what happens here is if we were to factor this, we would end up with x plus something and x plus something. One of the reasons why I know that it's going to be plus something and plus something is because the 10 has a positive in front of it. But when we're making a perfect square trinomial, what we put in this blank spot that I have right here has to be the same number in each parentheses. So in other words, what two numbers, when we split 10, hence split the middle, are we going to put in there that will combine to be 10? 5 and 5. So, what we want to know is, what does C equal? And where we get that value of C is we get it by multiplying those two together. So C, in this case, is 5 times 5. And ultimately, C is 25. Now, for a couple of you, you're probably going, yeah, I got nothing here. But what helped earlier is, if I did the whole factoring here, this would be x squared plus 5x plus 5x plus 25. And notice that 5x and 5x will give us 10x. And then the 5 times 5 in this last term is where we get that 25. And we'll be working with that on our complete notes today. So that's gonna, I think we'll be able to get you to understand that if you don't understand it yet. Y squared minus 8y plus c. Same kind of thing. We want to create a perfect square trinomial. So that means that our factors have to be the same. So in this case, it's going to be y times y, but this is minus 8. So this time it's got to be minus and minus. And how are we going to split 8 so that we have the same factors? 4 and 4. You are never going to get a plus or a minus. Because if they're a perfect square trinomial, they have to be the same in both. But now, what we want to know is, well, what does C equal? Well, C is going to be negative 4 times negative 4. I'm really sorry, I'm squeezing that in. You can't see it very well. Negative 4 times negative 4. And negative 4 times negative 4 is positive 16. Again, I'm going to skip letters C and D because we've kind of taken out the values of fractions. If you really want to know what C equals, it is 9/4 and D is 49/4 if you want those. But we're not going to focus on that this year. But what I want to try to figure out here is, can we come up with a rule for this so that we don't have to do all that work to get it? Have any idea what we might do? Well, we divided, and put it in quotation marks, B. You know what I'm talking about when I talk about B? So in case A, it was 10x. In case B, it was the negative 8y. That's the B. And more specifically, it's 10 and negative 8. Divide B by 2. 10 divided by 2 is 5. Negative 8 divided by 2 is negative 4. Then what did we do? And we squared it. Square that value. B divided by 2, then square it. That's a preliminary. That's a technique that we're going to have to use when we use this new method called complete square. You may have studied this concept in Algebra 1 or not. Some have and some haven't, to the best of my knowledge. Today, we're going to specifically talk about the fact when A, the number in front of the A, is 1. Tomorrow, we'll take it a step farther when the number in front of A is not 1. But in general, the steps to solving an equation by completing the square, we rewrite the equation in the form x squared plus bx equals c. What I tend to say on this is put the variables on one side and put the constant on the other. That's where we start. Variables on one side, constant on the other. Second step, which we're not going to use today, says divide all the terms of the equation by the coefficient of x squared. If it isn't 1. Today it's going to be 1. So that's the step that we're going to have to use tomorrow. Step 3, we're going to complete the square by adding b divided by 2 squared. That's what we just wrote. Divide b by 2, then square it. That's that. And we have to add that to each side of the equation. We're going to factor the trinomial. We're going to find the square roots. And then we're going to solve for x. And in general, when you see math in words, it doesn't necessarily make as much sense as it could have. So let's flip our paper over and look at a couple of examples. So the steps are written up there, but I'm going to quickly pull that out of the way. Solve the following problems by completing the square. Leave answers in simplest fraction form and or simplest radical form. No decimal answers. So the first one, x squared plus 8x plus 3 equals 0. Our first step, put the variables on one side, the constant on the other. Don't get too far ahead of me because I'm going to add something in. When we subtract 3, both sides, what we want is we get x squared plus 8x plus something equals negative 3 plus something. And if you infringe upon that space in the quadratic formula, fine. I'd rather you have the complete the square example. to figure out what goes in that blank space, and by the way, some other teachers like to write it as a box. It makes no difference to me. Because we're adding something to one side, we have to add it to the other side. We need to keep the equation in balance. But what goes in that blank space, what goes in that box, is step 3, which says complete the square by adding b divided by 2 squared to each side. In this case, b is 8. Divided by 2, which is 4. And then we're going to square it. Well, 4 squared is 16. We're going to add the 16 on the left side of the equation, and we're going to add 16 to the right side of the equation. Next step, let's factor the trinomial. Well, rather than split the middle every single time, because I don't want to split the middle when the middle is problem, if you take the time to write this blue step that we did, 8 divided by 2 squared, if you take the time to do that, when we factor, remember we're turning this into a perfect square trinomial, which means that this is x plus 4 and x plus 4. And where did my plus 4 come from? It came from the blue 4 off to the right of the screen. Right here. 4 squared. I took the 4. So that can save us a little bit of time when we're factoring. Over here on the other side of the equation, we're going to do the math. Negative 3 plus 16 equals 13. So we factored. Let's condense this down. It's a perfect square trinomial. X plus 4 times x plus 4 can be rewritten as x plus 4 squared equals 13. Which brings us to our next step. And our next step says, find the square roots. The inverse operation of squaring is square rooting. Squaring and square root cancel each other out. So if we square root the left side of the equation, we need to square root the right side of the equation. Again, square rooting and squaring cancel each other out. So we end up with x plus 4. Over here, we've got the square root of 13, but we need one more little piece. We need to remember that positive times positive is positive, and negative times negative is still positive. So this is going to be plus or minus square root of 13. And finally, we need to solve for x. What's x plus 4? We're going to subtract 4 from both sides. We get x equals negative 4 plus or minus square root of 13. If you still have space, let's look at the answer of the quadratic formula. I'm going to flip a page here. But once again, it's the same equation. It's x squared plus 8x plus 3 equals 0. But when we're using the quadratic formula, we're going to say a is 1, b is 8, c is 3. When we fill in this quadratic formula, we get x equals the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And I know I went pretty quickly here. I want to spend my time more on completing the square. This is negative 8 plus or minus 64 minus 12 divided by 2. And 64 minus 12 is 52. we are not done here. We need to ask ourselves, can we simplify the square root of 52? And as we think about it, at the very least, 2 times 26. And 26 is 2 times 13. And I wish I would have written that in a different color, but ultimately what happens is that this is 2 times 2 times 13. And when we're simplifying the square root, we're looking for 2 of the same value to take out 1. So this is going to become 2 times the square root of 13. And that's what's going to replace the square root of 52. It's going to be 2 times the square root of 13 divided by 2. And we're almost done now. The thing to notice at this point is that negative 8 is an even number. And 2 is an even number, and the denominator of 2 is an even number. To finish this, we get x equals negative 8 divided by 2 is negative 4. 2 divided by 2 is 1 square root of 13. Well, if we compare that, especially in your paper, you can see it. If we compare that back to our answer that we just got, what do we notice? It's the same answer. And it should be. We're learning how to solve problems with different techniques. Factoring, graphing, quadratic formula, complete the square. But I want to focus my remainder of my time on completing the square. So once again, our first step, put the variables on one side, the constants on the other. So in this case, we're going to subtract 30, both sides. We'll get x squared minus 10x plus something. Put a box if you want a box. Equals negative 30 plus something. To figure out what that something is, that's going to be our step 3, which is going to be negative 10 divided by 2 squared. B divided by 2 squared. Negative 10 divided by 2 is negative 5 squared. And negative 5 squared is negative 5 times negative 5, which is 25. If you take the time to write that step that's in blue, then the factoring, I hope, will be very easy for you. Because the number to the farthest right of the screen, which is negative 5, is what our values in our parentheses are going to be. X minus 5 times x minus 5. That will give us a perfect square trinomial. Over here to the right, negative 30 plus 25 is negative 5. Condense it down. X minus 5 times x minus 5 means the same thing as x minus 5 quantity squared equals negative 5. That leads us to our next step, which is take the square root of both sides. Square root is the inverse operation of squaring, and squaring and square rooting cancel each other out. And we end up with x minus 5 equals, once again, don't forget, plus or minus square root of negative 5. But just like we weren't done when we had the square root of 52, we're not done when we have the square root of negative 5. This means the square root of negative 1 times the square root of 5. What does the square root of negative 1 equal? I. And at least a few of you said it. Because the more you say it out loud, the more you're going to remember it. This is x minus 5 equals plus or minus I. radical 5. And finally, we need to solve for x. It's x minus 5, so we're going to add 5 to both sides. And we'll get our values of x. 5 plus or minus I radical 5. When we get an answer like that, can we factor? No. We've got an I and a radical in there. We can't factor that. And in fact, completing the square is a method that's designed for when we cannot factor. But one last example, and I hope that the steps are helpful. And in fact, on problem number 3, the nice part in this one is that it's already set up in the form of ax squared plus bx equals c. We already have the variables on one side and the constants on the other. But as I set this up, for my first step, I'm going to write it as x squared minus 4x plus something equals 2 plus something. And we need to determine what that something is, which is step 3. In order to compute that, we're going to take b, which is negative 4, divide by 2, and square it. By the way, it's always divide by 2. Negative 4 divided by 2 is negative 2 squared. And negative 2 squared means negative 2 times negative 2, which is positive 4. So as we take a look at this here, that leads us to our factoring. And if we're paying close attention, if we take the time to write that stuff that's in green this time, to the farthest right on the screen is that number negative 2. When we factor, this is going to be x minus 2 and x minus 2. When we look to the right of our equal sign, 2 plus 4 is 6. Condense this down. X minus 2 times x minus 2. It's a perfect square trinomial. Becomes x minus 2 squared equals 6. And then we're going to take the square root of both sides. Square rooting and squaring undo each other. They're inverse operations. So the square root of x minus 2 squared is simply x minus 2. And once again, don't forget over here on the right side, when we take the square root of 6, we need to deal with both the positive value of the square root of 6 and the negative value of the square root of 6. And to finish, we need to solve for x. So we're going to add 2 to both sides. We'll get x equals 2 plus or minus the square root of 6.